Welcome to the video. We are going to solve sum of leaf nodes in binary search tree BST. In this question, we are given a binary search tree and we have to return the sum of all of its leaf nodes. See in example 1. This is the input binary search tree. There are three leaf nodes 12, 45, and 78. We'll just sum them and return their sum. Example 2. We are given just one node which will act as root and leaf node itself. Okay, so it will represent the leaf and root node itself, and this will be the sum of the leaf node. This question is marked as easy, and it is very straightforward. There are two base conditions: either we do not have the root or we do not have left or right subtree. If the base conditions do not hold, then we will just return the sum of recursive sum of left subtree and recursive sum of right subtree. We'll just go down deeper, not the sum of recursive left subtree. First, we'll go down to the if left subtree exists, we'll go down to the left subtree, and at the end, when we have received a point wherein there's no further root nodes below, then we know that this is where we have reached the end, and this is where leaf is. We'll return sum of it. Let's see how I do it. First of all, if not root, if there's no root, return 0. If there's no root, there'll be no leaf node, there'll be no sum. Then second base condition, which is very crucial, if not root dot left and not root dot right. This is the condition which tells us we have reached particular node, which is the leaf node, and there's no left or right anything after it. So this base condition will tell us that we have reached the leaf node. At that case, we'll return data of this root, return root dot data. Cool. Now, if we are in the middle or in the root, in any such case, we'll recursively go deeper towards the left subtree, right subtree, get the sum and return the sum. Okay, so how we will do it? Just one single call, return search for sum of leaf nodes. Okay. Self I taken care of, then root dot left. Similarly, yeah, root dot left and root dot right. It should do the job. This is where we are going recursively deeper towards left subtree and right subtree. And inside any such case, if we will reach the leaf node, we'll return sum through this one. So as you can see, it took very less time and did the job very effortlessly. So this is one of the coolest algorithm in order to find the sum of leaf nodes. I have also attached a Medium article in the description in order if you want to get more understanding of it. Thank you. Have a nice day.